All right, I'm going to take a look at numbers 37 and 38 here. This is from section 5.2 of the pre-calculus textbook by Stewart, Redlin, and Watson. Um, 37 says, find the sine of point 1, or use the picture to find the sine of 1. Well, 1 is 1 radian, but the way they're thinking of it, they've got a unit circle drawn here. Right? I can see that the radius is 1. And so what they have is on the circumference, they have marked off, it looks like in units of 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10. Well, 0.10 is 1. So 1 along the arc is right there. But because this is a unit circle, the radius is 1. And so the angle and the arc are the same. So the angle from here out to there is 1 radian. The distance along the curve is 1, however much we're measuring distance in. If the radius is 1 mile, then this is 1 mile, right? But if this is 1 centimeter, then that's 1 centimeter. And the angle is 1 radian. So they want to know the sine. Well, on the unit circle, well, for any, sine should be x over r. No, sine, that's cosine. Sine should be y over r. So I need the y coordinate divided by r. Well, r is 1, so it's just the y coordinate. So at this point right here, what's the y coordinate? Well, I'm going to take, I'm going to drop a perpendicular over to the y-axis, and it looks to me the y coordinate there is right around 0.8. Now I don't know exactly what it is. I'm just approximating. It looks to me like it's a little bit bigger than 0.8. So I would say that the y coordinate there is 0.8 something. All right. The answer in the back of the book is probably just rounded to the nearest whatever. I would probably call it 0.82. I don't know. Just guesstimating how far. It's somewhere bigger than 0.8. It's somewhere less than 0.9, but it's closer to 0.8. Okay. Cosine, I'm looking at number 38 now, cosine of 0.8, so rather than 1, I'm going to look at this point right here, because that would be 0.1, 2, 3, 4, 5, 6, 7, 8, that's 0.8. The cosine then would be the x-coordinate, so I got to drop a perpendicular down to the x-axis. I'm using this edge to be along the x-axis so I can tell that I'm actually perpendicular. All right, so that looks pretty good. Drop a perpendicular down, and that looks like it's right at 0.1, 2, 3, 4, 5, 6, 7. That looks to me like it's right at 0.7. Again, I don't know how well did I line that up, how exactly straight up and down, I don't know. But I'm reading the x-coordinate. I'm dropping down to the x-axis here so I can read what that x-coordinate is of that point. Right? For number 37, I read what the y-coordinate was of this point. When I think of trig functions, I think of them as ratios of sides. X over r, y over r, x over y, y over x, whatever. In the special case of an angle being in standard position and that terminal point that you're choosing being on the unit circle, the radius is 1. So when you say x divided by r to get cosine, well, you're doing x divided by 1, so you're just getting x. So on the unit circle, the x-coordinate, right here in this case 0.7, is the cosine of that angle, 0.8. Likewise, for the 37, the y-coordinate divided by 1, which is just the y-coordinate, is the sine of the angle that we did there, 1. So anyway, you're doing your best you can to figure out what those x and y's are by just dropping a perpendicular over to the appropriate axis and seeing where it hits. Okay, there you go.